Hello, good morning, my dear students. I hope you are all doing well. We are still dealing with tangents and circumscribed angles. Today we are going mostly to do some activities about the theorems you've seen yesterday. All right, so let's go together to check the first activity. Now, I have Km and Kn are tangents to circle C. Explain how do you show that Km is congruent with Kn using congruent triangles. Okay, since this session is activity session, I want you to pause at each question. Take some time to think about the solution. After you're done, just play the video to see my answer, and you compare your answer to mine. Okay, pause the video here. Think about this question. All right, what I'm going to do here, I'm going to draw this segment KC. Now, the question said, using congruence of triangles, prove that Km is congruent with Kn. So, drawing this line shows me two triangles here. Now, I have KC, which is a common side. So, this is the congruence of one side. And I have MC congruent with NC. MC is congruent with NC. Why? Because MC and NC both are radii of my circle. Radii is the plural for the word radius. Okay? So MC is congruent with CN. Okay? That's the second side. Now, we have from the tangent radius theorem that the angle M here is what is a right angle. Also, the N is a right angle. Why? Because Km is a tangent for my circle at the point M. So, Km is perpendicular to MC, and Kn is perpendicular to MC. So, I have one common side, two congruent angles, and two congruent sides. SSA, okay, from the SSA congruence, then this triangle here is congruent with this triangle here. Very good. Now, if they are congruent, what does this mean? It means their corresponding parts are also congruent. So, Kn is congruent with Kn. Let's move to the second question. Okay, suppose you drag the point X so that is in a different position on the circle. If I move the point X, let's say, here, or here, somewhere else, okay, in a different position in the circle, does the measure of the angle OXY changes or not? I'm talking about this angle. Does this change or not? Explain. So if I'm dragging X, for example, this place, so I will have XY, and this is OX. Now, this angle in between, does it change or not if you are moving X? Pause the video, think about the question. Okay, then place to see my answer. Okay, so here I have a few examples of X. So I drag X to this position, I drag it to this position, for example, 3 examples. Now, at each point, all the time, the angle between XY and XO is always 90 degrees. So, the tangent radius theorem still holds at every position. So, XY is always measuring the same, which is 90 degrees, whatever X is. Okay, as long as your line XY is tangent to my circle, then it will be perpendicular to the radius of circle, regardless the position. Okay? Now, in the figure, RQ is a tangent to circle P at point Q. Now, what is the measure of the angle PRQ? I'm looking for this angle that is yellow. Alright? Now, we know that RQ is a tangent to my circle. So what can we say about the angle Q? It is 90 degrees. All right. Now, this is 90, this is 59. I'm looking for the angle R. This is very easy. The sum of the angles of my triangle will be 180. So the measure of PRQ, this one that I'm looking for, plus the measurement of RPQ, which is 59, plus the measure of PQR, which is 90 degrees because of the tangent. Now this sum is equal to 180 degrees. Okay, I have two known angles. One is 59, which is P, and Q, which is 90 degrees, and I'm looking for R, or PRQ. Then, okay, substituting your values here, then PRQ will be 31. So the angle PRQ is 31. Clear? Now, let's take this example. Let's go one step further. So, you know the International Space Station. You can check it on Wikipedia and know a lot of information about it. It's made on space by different countries. Very big project in the space. So, it is near to the Earth. Suppose it is at the position E. This is the Earth, okay? This is a picture of this International Space Station. Okay, it's orbiting the Earth at altitude of about 240 miles. So, my International Space Station is above the Earth by this distance, yellow distance, which is 240 miles. Now, in the diagram, the space station is at point E, as I said. Now, the radius of the Earth is approximately 3,960 miles. The red one. This is the radius of the Earth. This is representing the Earth. Now, to the nearest 10 miles, what is EH? Now, I'm looking for EH. Now, what is the nearest point between the International Space Station to the horizon? Okay, which is at point H. I'm looking for this length, blue one, okay, EH. Now, how can I find this length? Pause the video for a few minutes, solve this question. If you're ready, play this video to see my answer and compare it with yours. Okay, first we have that CD, okay, equals to CH. D is exactly on the surface of the Earth. Okay, this represents the Earth. So the length CD is equal exactly to the length CH. Why? Because both of them are radii for my circle. This is radius and this is radius for the circle. They are equal. So the length CH equal to the length CD. Good. And it is equal to the radius of the Earth, which is 3,960 miles. Okay. Now, what is ED? This length here, ED. It is 240. Okay, it's given. Now it's above the Earth about 240 miles. So the length ED is 240. Now what is the total EC? Is ED plus DC, which is 3,960 plus 240, which is 4,200 miles. Now I have CE, that is 4,200 miles. All right. And I have CH, which is the radius of the Earth, which is already 3,960 miles. Now, this triangle here is a right triangle. Now, I am allowed to use Pythagorean theorem. So, hypotenuse squared equals to the side squared plus the side squared. Great. Now, EC squared, which is 4,200 squared, equals to EH squared, which is the unknown, plus 3,960 squared, which is the radius of the Earth. Now, what is EH? Of course, it's 4,200 squared minus, I take this to the other side, minus 3,960 squared. Okay. Now, EH squared is 1,958,400. Now, I take the square root of this number. It gives me 1,299. Now, this is not the final answer. Why? Because therefore the question says to the nearest 10 miles. So you should approximate your final result to the first 10 miles. So This is what I got from my calculation. So I will add to it 10 miles. That's the approximation that is required by the question. So 1,399 plus 10 gives you 1,400 miles. So EH is approximately 1,400 miles, which is this distance over here. Great. Okay, now let's work a little bit with circuits on the coordinates plane. Now, find the length of each radius, identify the point of tangency, and write the equation for the tangent line at the point. Okay, this line here is the tangent. Okay, I want to find the coordinates for the point of tangency. Remember, we said the point of the tangency is the point where my tangent touches the circle, so which is this point in this example, and it is this point at this example. All right, and after that, we need to write an equation for this tangent line. So the radius of the circle is 2 units in this example, 2 units. So 1, 2, that's the radius of my circle. Also, you can look it up from here. On all sides is 2 units. Okay, and the point of tangency is 3 and 4. X3, okay, and Y4. This is the point of tangency exactly here. Now, we answered the first part of the question. Now the second part asks for the equation of my line or my tangent. What is this equation? Of course, it's y equals to 4. Look, this is 2 units, this is 2 units. So y equals to 4. This is the equation of the line here. Now for the other example, I have a tangent that is vertical. Okay, it touches the circle at this point. What is the coordinates of the tangential point or tangency point? It is -3 plus 1. -3 plus 1. This is the point of tangency. Now, what is the equation of the line? So, at each point here, x is all the time equal to -3. So, we say that the equation of this line here is x equal to -3. All right. Now, finally, we have a little homework here. So, the segments at each figure are tangent to the circle at the points shown. Okay, so AB is a tangent for the circle D at the point B. AC is a tangent for the circle D at the point C. In the example 10 also, SR is tangent to my circle at the point S. RT also is a tangent to my circle at the point T. The length AB is 2x squared. The length AC is 8x. And here SR measures to y. RT measures to y squared over 7. Alright. Now we want you to find each length. Find what is AB, what is AC, what is SR, and what is RT. That's the homework for today. Give your solutions, upload them to Google Classroom. Okay, again, it's different than the classrooms assigned by the school. That's my classroom. I wanted to use it because I prefer to create a special classroom only for math. So it's not going to be confusing. Like, I don't like the class to have all the materials at once. So I want to create only one class for my material, which is math. So please go there, sign in, put this class code to join it, and you will see that homework there assigned. So upload your answers over there. If you have any questions, also write your comments there. I can see them and answer anyone. Alright guys, take care of yourselves. Use sanitizers, stay tight, keep yourself safe, and see you tomorrow. Bye.